All right, we are moving on with our circles unit and into congruent chords and arcs. So how can I use properties of chords and arcs to solve problems? All right, what are the properties of chords and arcs? So two chords are congruent if and only if, and that's this symbol here, if and only if symbol has two arrows on the line, okay, if the corresponding arcs are congruent. Arcs are congruent. So here we have arc AB congruent to arc CD, okay, and that makes chord AB congruent to chord CD. So let's go ahead and write that down. This chord AB is equal to chord CD, and the measure of arc AB is equal to the measure of arc CD. Okay, so that's the first property. The second property states that two chords are congruent if and only if they are equidistant from the center. So we have chord AB equal to chord CD if and only if EF, so segment EF, is the same distance as segment EG. Okay, and final property, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. Then it bisects the chord and its arc. Okay, so perpendicular means crosses at a right angle. So the diameter or radius is perpendicular to a chord. So here we have a radius EH perpendicular to chord AB. You can see it crosses at the right angle. So EH is perpendicular to AB. Then it bisects the chord in its arc. So that means that it's cutting the chord and the arc in half, right? Bisects means cuts in half. So we can say that segment AF is equal to segment FB. And we can also say chord AH, the measure of the arc AH is equal to the measure of the arc HB. Okay, so let's go ahead and solve some problems using these properties. And I'm going to do the left side and I'll leave the right for you guys to complete. So the first one, number 1, sorry, these aren't numbered. We're going to do 1 and 3 together now. Okay, 1 says find xy. So let's find xy. We have two congruent arcs. So that means that we can set the chords equal to each other. So we are going to do 9x minus 34 equals 4x plus 1. All right, let's subtract 4x on both sides, giving us 5x on the left, and add 34 to both sides, gives us 35 on the right. Okay, and then we divide by 5 to get x equals 7. Okay, so that's the first part of the problem. Now we are going to plug it in to find xy. So here's our xy. xy equals 4x plus 1, and 4 times 7 plus 1 is 28. 29. Scratch that. So let me erase 29. We can add. Okay. Let's move on to number 3. So we are going to find x, and we're given 2 congruent chords this time, and need to find what is x. Okay, well, if we have 2 congruent chords, we also have 2 congruent arcs. You guys agree? So if this one here from y to z is 6x minus 20, okay, this one's also 6x minus 20 degrees. Okay, and we know that a whole circle is 360, so let's find 360 minus 76 to find what these arcs could be. So 360 minus 76, and 35 minus 7, that's 28, is 284. So we know that 6x minus 20 plus 6x minus 20 is going to be 284. So let's just do 2 times 6x minus 20 equals 284. That's 12x minus 40 equals 284. Okay, we'll add 40 to both sides. That gives us 12x equals 324. And let me get my calculator. Okay, so we have 324 divided by 12 will give us x equals 27. Okay, so go ahead and pause the video and complete number 2 and 4, and then come back and we're going to do the next 2 problems together. So pause the video now. All right, welcome back. We are going to do number 5 and 6 together, and you guys can do 7 and 8 on your own before you turn it in. So it says for number 5 and 6, use the circle below. And we are going to try to find chord VW. All right. So they don't give us much to go off of here. We are trying to find this chord. All right. But we see this right angle here. So we have a radius that is perpendicular to a chord. So that means that it is bisecting or cutting in half that VW. So we could technically find, and let me find this x length and multiply it by 2 to find the chord VW. And we have a right triangle. You guys want to guess? We're going to use Pythagorean theorem. So we give us 2 legs, and we're going to find, or sorry, they give us a leg and a hypotenuse, and we're going to find the other leg. So let's do 5 squared plus x squared equals 13 squared. 5 squared is 25 plus x squared equals 169. Subtract 25 on both sides. We get x squared equals 144. And then take the square root, and we get x equals 12. Okay, so if half of that chord is 12, VW is twice 12, 24. Okay, if you have any questions on that one, send me an email. Okay, number 6 says, find the measure of arc WY. or YW. So we're trying to find this arc here. Okay, so what do we know? Can I erase this? We know that a central angle is equal to its arc measure, right? So we could find the central angle using trig, right? Because we have a right triangle. And we're given, this would be across from this angle. We're not given the opposite. We are given the adjacent. And we are given the hypotenuse. Okay, so if we're given the adjacent and the hypotenuse, what are we going to use? Okay, so I'll put it up here. SOHCAHTOA. So we're given the adjacent and the hypotenuse, yet let's use cosine. Okay, so we'll call this cosine of angle x is equal to 5/13. Okay, I wonder if my calculator here has my trig functions. No, so I'm going to use my phone calculator, guys. Okay, and to get x by itself, we have to use inverse cosine of 5/13. Sorry, that's a 3. 5/13 is 67.4 rounded. Okay, so if our central angle is 67.4, then the measure of our arc, YW, is equal to that. It's also 67.4 degrees. Okay, so you guys are going to do number 7 and number 8. And number 7, you're going to use Pythagorean theorem. And number 8, you're also going to use trig again. Okay? And if you need help, send me an email and do your best. Okay? Thanks, guys. Good luck. Bye.